Now, videos 1310 through 1314 were interrupted by a glitch in the camera or the computer, more likely the computer software, and the pictures got shrunk way down, difficult to read. So I'm not going to repeat all the explanations, but I'm simply going to go through these very quickly at a higher resolution so you can see more clearly what was written. We're looking at the divergence in the curl. Divergence is the del operator with which you're familiar from using it to calculate the gradient, and the curl, which is the del operator crossed with a vector function. And we've already seen examples of vector functions. You might want to think in terms of a couple of the functions we've already seen. So that the divergence of the vector function is del dot f. The f function is mi plus nj plus pk, where mn and p are functions of x, y, z, and the del operator is as we've seen it. So del dot x times I dotted with mi gives us del with respect to x of m, del x with respect to m. Then we add the product of the j components, not actually a product, it's an operator of an operation on the n vector. Partial n with respect to y, we get partial p with respect to z, which is mx plus ny plus pz in another common notation. And as an example, we do the divergence of the function xi plus yj plus zk, one of the functions that we looked at in the preceding clip, so that del f, well, we've written it out here, I'm not going to read it to you, but we then perform the operation by applying the del with respect to x times the x, in other words I component times I component, gives us partial of x with respect to x. The y derivative applied to y gives us partial y with respect to y, and we get partial z with respect to z. 1 plus 1 plus 1 is 3. So the divergence of this function at any point, at any x, y, z, is 3. Now we look at the curl, which is del cross f. And we write this out in determinant form, the ijk vector, the del operator, and the components of the f vector. And doing the calculations, and you can look back at the original clip where the resolution wasn't good, but we see that we do the ij minor, which is this, multiplied by I, minus the j times the ij minor, giving us this, times the, well, the minor that we get by removing the j row and column. And then k times the minor that we have here. And we see that we have partial with respect to y of p, which is py, minus partial with respect to z of n, which is nz, times I. Partial with respect to x of p is px. Partial with respect to z of m is mz, so it's minus j times this difference. And very similarly with the k, so that we end up with this expression. Now this is not, as I believe I said previously, something that we want to simply memorize. We just use the cross product in whatever way is easiest to calculate, and often that will be by using the determinant method. Calculating then the curl of the xi plus yj plus zk function, we're going to find that py, well, that's what's p. P is m, n, and p are the components, the ij and k components of f. So px would be the z component, z would be z, the k component, and py would be 0. N is the x component, and z is 0. Derivative of x with respect to z is 0. Similarly, we're going to see that all these derivatives are 0, giving us 0 as the final result for the curl.